So this course is on power system analysis and stability, module 3, symmetrical fault analysis. So symmetrical fault analysis, so this module consists of need for short circuit study, types of fault, fault MVA, short circuit on an unbalanced synchronous machine, calculation of symmetrical fault current using Thevenin's theorem and Z bus. And what is symmetrical and unsymmetrical faults? So normally power system operates under balanced conditions. When the system becomes unbalanced due to the failures of insulation at any point or due to the contact of live wires, a short circuit or the fault is occur in the line. So due to the fault may occur in the power system due to the number of reasons like natural disturbances, for example lightning, high speed winds, earthquakes. Other than that, insulation breakdown, falling of trees, birds shorting, etc. So the faults are occur in transmission line or broadly classified as symmetrical faults and unsymmetrical faults. So this module will deals only with the symmetrical faults. So in such a type of fault, all the phases are short circuited to each other and often to earth. Such a fault is balanced in the sense of that the systems remain symmetrical, the lines displaced by an equal angle, that is 120 degrees each other. It is the most severe type of fault involving largest current, but it is occur rarely. So this balanced circuit calculation is performed to determine these large currents. Then what is the need of fault analysis? So in this fault analysis, we have to determine the magnitude of fault current throughout the power system after the fault occurs. To select the rating of fuses, accordingly breakers, and accordingly switch gears according to the rating of all these things with respect to fault analysis. To check the MVA rating of the existing circuit breakers when the new generators are added into the system. So that's why we need a fault analysis in symmetrical fault. And common power system faults are, there are 4 types of faults are commonly used. So in this power system, fault may be categorized as one of the 4 types. So in order of frequency of occurrence, they are single line to ground fault. The maximum frequency of occurrence of fault is single line to ground fault. After that, line to line fault. After that, double line to ground fault. Finally, balanced 3-phase fault. This balanced 3-phase fault will be a severe fault and it is rarely occurs. And what is a fault MVA? So in this MVA method is a modification of ohmic method where the impedance of the circuit equals the sum of the impedances of the components constituting the circuit. So using the admittances, it follows the that the reciprocal of the system impedance in the sum of the reciprocal of the admittance of the components. So the circuit components admittances is the maximum current or kVA at unit voltage which would flow through the circuit or the component to the short circuit or the fault when the supplied from the sources of infinite capacity. And we have to go with the symmetrical faults in a synchronous generator. 3-phase fault current transients in synchronous generator. Accordingly, when a symmetrical 3-phase fault occurs at the terminals of the synchronous generator, the resulting current flow in the phases of generator can appear as shown in figure. So here we have to consider the current as well as the fault at the phase of A. So the phase A, the fault current is a DC component because almost all the alternating sine wave of fault current only occurs at the negative side. So this is called the DC component. Another one, if the phase B, the current can be represented as a transient DC component added on the top of the synchronous AC component. So in the previous case, all the phase A current will be totally negative, but in the case of phase B it become positive. So this is also a DC component. And the third phase is in combination, and therefore while before the fault only AC voltages and the current were present within the generator. So immediately after the fault of both AC and DC currents are present. So in this component of phase C, AC component and DC component both are present. So this is the three phase fault, balanced symmetrical fault. So the fault current transient in machines. So normally in machine, what are the fault current in transient in the machine is it is categorized into three part. One is subtransient, after that transient, and finally it come to steady state period. Then what is the subtransient envelope? It is very short duration and rapidly fall down. So short circuit current, according to the short circuit current, the subtransient envelope are very short period and rapidly fall down, and extrapolation of a transient envelope. And the next one is the transient envelope. There will be a changes in the transient envelope is it will be slower, but it is not come to steady state, but there will be a rapid change on that. So finally we can reach the steady state. So this is the three phase synchronous machine or three phase fault at the synchronous generator. So there are three components of three components. One is subtransient period, the first cycle or after the fault occurs. It is AC current is very large and falls rapidly. For the transient period, current falls at a slower rate, and steady state period, the current reaches its steady value. So it is possible to determine the time current for the subtransient and transient period. So in this graph, in this figure, it is clearly given that short circuit current depends upon three periods of subtransient, transient and steady state period. Thank you.